Imagine capturing secret US spy satellites with nothing but a backyard telescope. What secrets are orbiting above us, and how can an amateur astronomer unlock them? Could it be possible that a hobbyist uncovered classified information hidden from the world? In the hidden world of space-based espionage, satellites quietly circle the Earth, carrying out missions that are cloaked in secrecy. These high-tech machines, launched by powerful agencies like the U.S. Space Force and the National Reconnaissance Office, perform critical roles in intercepting signals, tracking missile launches, and monitoring the globe with astonishing detail. The public knows little about them until now. Meet Felix Schöfbänker, an amateur astronomer from Upper Austria. With just a telescope in his backyard, Felix has managed to do the unthinkable, capture detailed images of classified spy satellites. His findings have opened a window into the secretive world of military space operations. But how did he do it, and what did he uncover? This video will take you on a journey into the fascinating realm of space observation, where hobbyists with a passion for astronomy are revealing things previously hidden behind a veil of secrecy. Felix Schöfbänker's discoveries challenge the notion that only powerful governments hold the keys to space intelligence. As we dive deeper, you'll see how one man, with his 14-inch Dobsonian telescope, managed to reveal details about cutting-edge US spy satellites, shedding light on both their technological marvels and the mysteries they carry. What could these revelations mean for global security, and how might governments respond to amateur eyes peering into the skies? Spy satellites, or reconnaissance satellites, are some of the most advanced and secretive tools in modern intelligence. They operate high above the Earth, silently carrying out missions for defense, surveillance, and data collection. These spacecraft perform tasks such as intercepting communications, detecting missile launches, monitoring military activity, and even capturing high-resolution images of specific locations on the planet. From optical systems that can zoom in on objects smaller than a car, to radar technology that penetrates clouds and darkness, these satellites are a critical asset for national security. Agencies like the U.S. Space Force, the National Reconnaissance Office, NRO, the CIA, and the National Geospatial Intelligence Agency, NGA, are responsible for developing, launching, and operating these satellites. Their missions are often classified, ensuring that only a handful of people have access to the information they gather. It's no surprise that governments go to great lengths to keep the existence, capabilities, and locations of these satellites secret, protecting them from potential adversaries who might seek to counter their operations. The cloak of secrecy surrounding these satellites serves a crucial purpose. First, revealing the capabilities of a spy satellite would allow rival nations to develop countermeasures, reducing the effectiveness of the satellite's mission. For instance, if a country knows exactly when a satellite is passing overhead, they can take measures to hide sensitive activities, rendering the satellite's surveillance useless. Additionally, the technology on board these satellites is highly sensitive, and exposing it could give competitors valuable insights into how to replicate or disrupt these systems. Furthermore, the mere presence of these satellites can influence global politics. Knowledge of when and where satellites are positioned may shift the balance of power in strategic conflicts. This makes spy satellites not only tools of intelligence but also instruments of diplomatic leverage. By keeping these spacecraft under wraps, countries like the United States can maintain a significant advantage in global surveillance. Yet, despite the sophisticated measures taken to keep these satellites hidden, they are not completely invisible. The growing community of amateur astronomers and satellite trackers has begun to chip away at the veil of secrecy. Using relatively simple equipment, hobbyists have been able to detect, track, and even photograph classified satellites. While these images don't match the resolution of government observatories, they offer glimpses into the positions, designs, and movements of spacecraft that were meant to stay hidden. Felix Schöfbänker is one of these amateur satellite watchers who has taken his passion for space observation to the next level. Equipped with his telescope, Schöfbänker has managed to capture highly detailed images of some of the most secretive spy satellites orbiting the Earth. His work highlights how, even in a world dominated by high-tech intelligence operations, individuals can still play a significant role in uncovering hidden truths about our skies. Felix Schöfbänker's journey into the world of spy satellites began with his passion for astronomy and a relatively modest setup, a 14-inch Dobsonian telescope. While this type of telescope is typically used by amateur astronomers for stargazing, Schöfbänker modified his to track and image satellites. His Dobsonian was equipped with satellite tracking capabilities, allowing him to precisely follow these fast-moving objects across the sky. By carefully adjusting his equipment and using specialized software, Schöfbänker was able to capture clear, detailed images of satellites that orbit hundreds of kilometers above the Earth. What makes his work remarkable is that he achieved this from the comfort of his own home in Upper Austria. Through trial and error, Schöfbänker honed his skills, fine-tuning his telescope and learning how to interpret the images he captured. This dedication paid off, as he began to document satellites that were part of highly classified U.S. reconnaissance missions. His findings have shed new light on these satellites' designs, missions, and capabilities, information that was previously only speculated or entirely unknown. One of Schöfbänker's major discoveries involved the U.S. spy satellites known as FIA radars, or TOPAZ, which are part of the Future Imagery Architecture (FIA) program. These satellites use synthetic aperture radar (SAR) technology, which is particularly useful for military surveillance because it can penetrate through clouds and operate both day and night. This makes them incredibly effective at capturing high-resolution images of Earth's surface, even in less than ideal weather conditions. From his images, Schöfbänker was able to deduce several important details about the design of these satellites. He observed that they are equipped with a large parabolic mesh antenna, estimated to be around 12 meters, 39 feet, in diameter, which is used to send and receive radar signals. In addition, he noted the presence of 2 solar panels, each with a wingspan of about 10 meters, 33 feet, which power the satellite. Between these solar panels, Schöfbänker identified another bright object, which he interpreted as an antenna used for communication between the satellite and ground stations. These satellites work by sending out pulses of radar signals towards the Earth. When the signals bounce back, onboard computers process the returned signals and generate detailed images of the surface. Schöfbänker's observations revealed that the FIA radars can point their antennas either to the left or right of their orbit to scan specific areas. Over the course of his observations, he found that the antennas were positioned to the right 22 out of the 28 times he tracked the satellites, providing insight into how they prioritize their surveillance targets. The images Schöfbänker captured of these TOPAZ satellites offer a rare glimpse into the classified world of U.S. military reconnaissance. While the details he has uncovered don't compromise national security, they do provide valuable insights for satellite enthusiasts and space researchers. Schöfbänker's work shows that, even in the realm of high-stakes intelligence, amateurs can make meaningful contributions to our understanding of space-based technology. For researchers and professionals in the field of space observation, Schöfbänker's findings confirm some theories and challenge others. His ability to document the structure and operational patterns of these satellites has added to the collective knowledge of how the U.S. manages its reconnaissance missions, specifically the balance between optical and radar imaging. In addition to radar-based satellites, Felix Schöfbänker also managed to capture images of another highly classified series, the KH-11 Kennen optical satellites. These satellites, first introduced in 1976, are often compared to the famous Hubble Space Telescope, but with one crucial difference: instead of looking out into deep space, KH-11 satellites are designed to look down at Earth. They are a vital part of the U.S. intelligence community's toolkit, providing detailed visual surveillance of strategic locations around the globe. Currently, KH-11 satellites are operational in orbit, spanning 3 different generations. The oldest, known as USA-186, was launched in 2005 and belongs to the 3rd generation of these satellites. The next 2, USA-224 and USA-245, were launched in 2011 and 2013, respectively, and represent the 4th generation. The newest, USA-314, was launched in 2021 and marks the 5th generation of KH-11 satellites. What makes these satellites especially fascinating is their high-resolution optical imaging capability. Schöfbänker's observations revealed that the design of these satellites has evolved over time, particularly in the size of their primary mirrors. The third-generation satellite, USA-186, features a mirror approximately 2.4 meters, 8 feet, in diameter, similar to the earlier generations of KH-11. However, Schöfbänker's images suggest that the fourth-generation satellites, USA-224 and USA-245, have larger mirrors, with an estimated diameter of about 3 meters, 10 feet. This increase in mirror size significantly improves their ability to capture finer details from space. While Schöfbänker hasn't yet gathered enough data to determine the exact specifications of the fifth-generation USA-314 satellite, his ongoing observations may soon reveal new insights. One of the most intriguing finds in Schöfbänker's catalog is a satellite known as USA-290, which has puzzled space observers. Launched in an unusual orbit and displaying a design different from typical KH-11 satellites, USA-290 has raised questions about its purpose and capabilities. Most KH-11 satellites are placed in sun-synchronous orbits, which means they pass over the same part of the Earth at the same time each day, optimizing lighting conditions for optical imaging. However, USA-290 does not follow this pattern, hinting that it may serve a different type of mission. From the images Schöfbänker captured, the satellite appears to have a large rectangular panel roughly 5 meters long, quite different from the familiar design of the KH-11 series. This observation has led to several theories about the satellite's function. One possibility is that the panel could be a radiator, part of a cooling system for an infrared imaging device, which would enable the satellite to detect heat signatures on the ground. Another theory is that it could be a phased array antenna, used for collecting radar images or intercepting signals, much like the SAR technology employed by the FIA radar satellites. Some observers have even speculated that the panel might be a solar array, providing energy to the spacecraft. However, Schöfbänker is skeptical of this idea, noting that the panel seems fixed in place. For solar panels to be effective, they usually need to rotate and track the sun's position throughout the orbit. This anomaly only deepens the mystery surrounding USA-290. Despite his detailed observations, many questions remain about the true nature of USA-290. Could it represent a new generation of spy satellites with capabilities we have yet to understand? Or is it part of a different kind of space mission altogether, designed for purposes beyond traditional optical or radar surveillance? What's clear from Schöfbänker's findings is that the world of reconnaissance satellites is constantly evolving, and new designs and technologies are being deployed in space all the time. The ambiguity surrounding USA-290 highlights the secretive nature of these missions and the challenges that come with trying to interpret what is really happening in the skies above. Felix Schöfbänker's discoveries remind us that even the most classified technologies are not beyond the reach of dedicated observers. His work raises fascinating questions about what else could be uncovered by curious minds with the right tools. As the skies above us become increasingly crowded with secretive spacecraft, the role of amateur astronomers may grow even more significant. What other hidden secrets might be waiting to be revealed? Keep looking up, because the next great discovery could be yours.